When I first started flying gliders way back when, we used to start with a 2-to-1 or even higher differential ratio, meaning the up ailerons were going up twice as much as the other ones were going down. You'd start there and then start backing that ratio off and then start adding a lot of rudder, because the rudders were smaller and the blades were smaller, to get a coordinated turn. And that definitely took a lot longer, but modern planes like this, it's a little bit easier. And now I start with no differential in any flight modes first. I'll fly the airplane, put it through some roll maneuvers at different speeds and kind of see how much adverse yaw I'm getting. That's without a rudder mix or adding manual rudder to get a coordinated turn. So I'll add, again, without the rudder, I'll play around with the differentials. I'll add a little bit of differential, see if I like that roll. I'm just watching the fuselage angle, see if it squats on the tail or anything like that during the maneuvers. And then I'll adjust the differentials accordingly. I want to have the least amount of differential as possible. Again, differential is not really an efficient way to combat adverse yaw on a turn. It's just not. So let's look at my cruise mode. Here's cruise, differential setting, 50-50. And that's the inboards also. Most radios can adjust the inboard differential as well. A lot of people miss that factor and they don't set the differentials up. So we'll have a lot of, because most flaps on airplanes don't go up very much, they'll go a roll, like for the down, they'll get a ton of down and not much up. And that's opposite differential for the inboards. So you want the inboards to track the same differential as the tips. That's super important. Now for thermal mode, which is your slower speed, you may want to have a little bit of extra differential because you're flying slower, the aileron's going to be less effective. But still on the Explorer here, my ratio still is right at about 50-50. You also notice I have a lot of aileron throw because I don't like to move the stick much to make the airplane roll. So in cruise mode, actually I have more throw. When I maneuver, I want to maneuver fast, and then my throw actually reduces with thermal mode a bit. So I'll fly a little bit smoother. Now once I'm happy with the differential without any rudder input, then I'll start dialing up the mix in the back. Again, keeping the mix as low as possible, keeping the amount of differential also reduced. So if I can get the differential to feel pretty darn good with just the ailerons working in harmony, and I'll start adding in some rudder mix and see how much rudder it takes to get that turn coordinated. So it's pretty easy to get, because there's going to be a sweet spot where that airplane turns without you even thinking about it. You watch the fuselage track cleanly through the turn without either over-ruddering it, where you get into a skid, or not enough rudder, not enough differential, where the airplane goes into a slip in a turn. Now, precision tuning of any glider really starts with a mechanical setup in the servo installation of your airplane, and that's for rudder, elevator, and the wing servos as well. This is the servo setup on my Explorer F5J here, and you want to note a couple of things. This is the rudder on this side, elevator on this side. So for any system, you want to maximize the resolution of the servo. And what that means is you want to have the servo go through its full throw to get the amount of throw in the back without really relying on the radio to do that for you. So for the rudder and elevator, I have the endpoint adjustment set just about all the way to max, and with the clevis mounted really close into the servo axle itself, that maximizes the resolution. So the servo is going to have to go through a lot of throw to get a little bit of throw in the back. That's really what you want to maximize your resolution. And that also gets rid of a lot of double centering issues as well. So even on the rudder, I have it run pretty far inside. You see a lot of people's installs where they have a big long horn and the clevis all the way on the end there. That just means the servo is going to move a little, they're going to get a lot of throw in the back, and they're going to have to tune down the radio and their endpoints way down, like 50% or something, to, so they don't get too much throw in the back. You can see the elevator here is also way inside, and I actually did a custom hole a little further than the factory hole, the last hole on their horn. So again, to maximize the resolution. So the servo's moving a lot to get a little bit of elevator in the back. What that does for you is allows you to set your trims more precisely, and that way when you're going through your flight modes and you set the elevator for that particular speed you want to fly, that elevator is going to move precisely to that position and hold that in center perfectly each time. So really go through your servo installs and maximize the throws and get rid of any double neutral or double centering that may occur. So the push rods here are shortened, they're all optimized, and the housings are carbon fiber to the side of the fuse here. So There's absolutely no movement, no slop in here. And I'm also using nice MKS servos here, which are really precise anyway. But doing the system of running it really far inside really gets the most out of the servo. Let's talk about rudder mixes, and let me show you my rudder mix setup on the Explorer F5J here. Now, this is like any modern sailplane where the rudders have gotten a lot bigger and also the moving surfaces have increased in size as well. And that's for increased tracking of the airplane with these big, long, high aspect wings, but also good landing control when the airplane's got the flaps down, it's coming in for competition style landing, and the airplane's flying slow. We have enough surface to be able to move that nose and get the airplane to hit that 100 spot if needed. You can see on the Explorer here, it's got almost a 50% chord where the hinge line is. So there's a lot of surface moving back here. And you can kind of think about this as a low aspect wing with a huge amount of flap here. But also remember, when you're moving the flap in the back, you're getting yaw force because you're curving this whole surface here, but you're also getting more and more drag. So at full deflection, that's quite a bit of drag, a lot of force of course, but a huge amount of drag. Now you want to minimize the drag in all your flight modes. And my philosophy on the mixes is less is more. One of the big problems I find when I'm test flying other people's airplanes and getting them set up is they have way too much mix on in all the different flight modes. You need a lot less mix or a lot less rudder usually in coordination with the differentials in the wing, of course, to get a nice coordinated turn so the fuselage isn't skidding or slipping. So less is more. Let me show you the flight mode for cruise. Remember, the mixes are speed dependent. The faster the airplane's running, the less deflection you're going to need in the rudder to get a coordinated turn. Again, in balance with the differential setup. So this is my cruise. Let's go full stick deflection. Full stick, you see how little that rudder's moving. That's all that's needed to get a coordinated turn and get crisp maneuvering. So that's like a moderate speed. Speed mode, I have about that much as well. Let's go to my thermal mode, which is my slow flight mode. Now let's look full deflection here. Over twice the amount of throw. And that's just for general maneuvering in thermal mode here. Now if I see the airplane is slipping or skidding in a turn, of course I have on my rudder stick quite a bit of throw available if I need it. If I find that the mix is not working correctly, and a lot of times the mix will work just fine, but I can get on the rudder here and I can add more or less. If I find the mix is, adding too much, I can back off that. Or if I need to really spin the airplane around hard, use rudder deflection and move that airplane around. So less is more. So a good tip for setting up rudder mix is I start with no mix. I'll fly for a little bit and I'll just start dialing it up. And I want to have the minimum amount of deflection because that's just extra drag. And what a lot of people are doing is they're flying around, they're moving the ailerons, they're getting a huge amount of rudder and more rudder than they need. So that's a big problem. I find hardly any people have too little rudder. So I usually start with 0 and I'll just start tuning it up slowly with each flight. And there's going to be a point where it feels good. A good exercise is to turn off your mixing. If you can put it on a switch, do that. And just, if you have your mix set up, turn it off, see how the plane feels. It'll probably feel pretty ugly. Turn it back on. And then one day go turn it all the way up to full and test that as well. And you can start to feel the difference between not enough mix and too much mix. And that way you'll kind of get a handle on how much rudder you're going to need for your particular flight mode and your particular speed you want to fly at. Now you can spend your entire flying career flying with a pre-programmed rudder to aileron mix and be absolutely fine and fly fine with that the rest of your flying career. But if you want to improve your performance a little bit, especially if your plane tends to need a little bit of opposite aileron in a turn, it's called top aileron. So let's go into our right thermal turn here. We get it set up, we got our bank angle set up and our speed set. But you're finding that you have to hold a little bit of opposite aileron to hold that. Well, what's happening with your mix? Because remember, the mix is following your ailerons. So now you've got a little bit of left aileron in the turn, but also you're getting a little bit of left rudder too. And that's a high drag situation because you're putting the airplane in a slip. And that means the airflow across the fuse is going to be a little sideways. And that's just a high drag way to circle around a turn. So if your airplane needs a little bit of top aileron consistently, think about your mix like my Explorer here, hardly ever needs top aileron. My Euphoria is very neutral in turn and almost never needs it. But if you're holding a little bit of opposite aileron, you've got to get it on your rudder stick to override that mix and put that right rudder back in. It's not going to take much, 5 or 10 degrees. You don't want to over rudder. 5 or 10 degrees to get that turn coordinated, get that fuselage realigned to the airflow, and make that a low drag turn. So think about that. Top aileron, opposite aileron, get on the rudder stick. Now, one of the problems about setting up modern thermal planes is that the clevis for the rudder, where it's being pushed, is right at the surface here. In fact, the Explorer is right at the surface of the rudder blade here. And it's pretty easy to introduce slop into the system. So if you have your servo with a really long arm on the front and your push rods aren't securely fastened, it's very easy to get a lot of slop back here, so the rudder is not going to center real well too. And also, if you don't have your servo resolution maximized in the front, that servo is going to move a little bit, but you're getting a lot of rudder throw in the back, which means that your control movements can't be that precise, and the rudder may not center correctly either. So it's very important to run, the servo on the inside of the horn, maximize your endpoints in the radio so the servo has to go through full travel, and that'll give you precise movement in the rudder. So even though you think you're getting a lot, you're moving the stick a lot, the rudder's not moving a lot, but it's going to be moving precisely to the correct position and also centering back. So pretty easy place to find slop, so make sure your rudder is precise. A lot of movement is not critical. Maybe in your landing mode you want a lot more rudder throw, but usually you don't need that much rudder to keep everything tight and precise. You can see I can move this one here. It's dead tight up front. There's no slop anywhere in the system. Now, with any sailplane you have, it's a really good idea to check the surfaces for double neutral or double centering. And this is the elevator on the Explorer here. You can see how it centers perfectly each time. I find this is a really common problem with guys' sailplanes that I fly and test out, is that the elevator just won't hold trim. And every time you pull up, the plane wants to stay kind of pulling up. Every time you push down, the plane kind of stays wanting to push down. So I can run through flight modes. You can see how very little the elevator is moving between flight modes. If your elevator can't be that precise with your push rod setups, the mechanical setup on your servo, and having your endpoints maximized, it's going to be really hard to trim the airplane for flight modes. You do that for rudder, do that for your ailerons, and flaps as well. Now you notice on the Explorer here how much of the moving surface really takes up the elevator here. This chord line is almost at 45%, not quite 50, but pretty far up. So almost half of the elevator surface is moving. And that's kind of a characteristic of a lot of these modern airplanes where they have long booms, very large elevators, whether it be all moving or a flapped one like this. So you can imagine if this elevator is not centering correctly or you don't have the resolution set up in the back, that small amount of movements can really change the speed or the pitch angle of the airplane. So if this is not centering precisely, even a quarter degree, you're going to get a pitch change, or say it's not centering within a quarter degree, the airplane's just never going to trim right. And when I hit my trims, I want to retrim for a certain flight mode. I want to make sure that this big surface moves precisely, but also recenters precisely each time. Otherwise, I'm going to have to keep retrimming. The airplane's never going to match the speed I want, and I'm going to be on the stick much more, really increasing my pilot workload. So with modern sailplanes, it's super critical to get that rudder to center correctly and have the absolute maximum amount of resolution in the system so you can be able to trim the airplane for whatever speed you want and be able to hold that trim regardless of your CG. Now, whether you have a full flying stab or a flap stab like this, a good test to do is when you have the servos off, is to just put some back pressure and see if there's any slop there. It's going to show up pretty quickly. It's either going to show up on the elevator end or somewhere in the push rods or down at the servo end. We're going to get a little bit of slop. I mean, you're going to feel a little bit of bending and maybe some resistance here. If you hear any clicking sounds or you're easily able to move that surface back and forth against the servo, you need to investigate that. It's usually a push rod issue or the push rod enters the horn either at this end or at the servo end. So investigate that and get that elevator so it's nice and tight. So it should be tight whether the servos are powered up or not.